Hey guys, welcome back to Computational Biology with Python. In this video, we're going to continue on with our analyzing data, analyzing patient data, that is. We ended with kind of the annotations of the numbering system of Python in the last one, and now we're going to move on from that into not as confusing things, hopefully. So let's get going. All right. So first things first. So I'm going to keep working on this analyzing patient data script. What I'm going to do, because we need the NumPy thing, I'm just going to go through and rerun all my previous commands. So let's go to the top, play them all, because I want that all loaded up if you've exited out between doing this video. If you're just continuing this video after the last video, you don't have to do that. But if you are starting over, then run everything because we need some of that stuff, like to load the data especially. All right, so let's use a NumPy function. Let's do print, and we'll do NumPy, and we'll do mean of data. So we're gonna say print the average, the mean of our data. So we get 6.14875. Good to go. So there's different, like I said, this is kind of the package that it looks for, and then the dot, and then what do you want from that package? And we say calculate the mean, and then we tell it what to calculate the mean on, which is the data. Remember, we saved data somewhere up here as the CSV that is over here. Okay. So let's use some other different NumPy functions to characterize this data set. So let's look at print maximum inflammation, and we'll say actually I think that's not going to work. Yep, so we have to do something before that. So we're going to do max val, min val, standard val equals numpy.amax data, numpy ammin data, numpy std data. Okay, so what we've done is, what's kind of cool about Python compared to like R is we've pretty much combined three different things together. So I'm gonna do it both ways. So in R, I'm gonna do it down here. Can I get rid of how do I get this? Okay. So in R, we'd have to do it like this: max val equals, or arrow, numpy. Even though the annotation would be different because we don't use the dot annotation or whatever, but bear with me. Min val, there shouldn't be an M on here. Let's just typo. Min val equals numpy a min data, and then standard val, not vat, this needs to be corrected, equals numpy.std data. So this is one way you can do it. The other way you could do it is you can actually smush all these together into one function, right? So this function says max val, min val, and standard deviation val, or standard val, equals, and then it assigns the first one on this side of the equal sign to the first one on this side, the first value or the second value on this side to the second value, and the third value to the third value. So if I print this, and then if I insert another in between, print max val, print min val, print standard val. So if I run these now, these are the values I get. So the max val is 20, the min val 0, and the standard deviation is this. So now if I run this, which will save over, what's going on here? NumB. Okay, let's try it again. Okay, so if I run this command, I'm going to copy this, Control C, Control V, paste it down here. I should theoretically get the same printout, right? Because this command is just merging of these three commands. So if I run this, 20, 0, 4.6, blah, 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 blah. So now if I did something like this, print, maximum inflammation, then I say max val, print minimum inflammation, and I say min val. I switched my keyboard, and I think I'm already a bad typer, but I think it's making me like a horrendous typer. Standard deviation, standard val. Okay, so now if I run this one, it should just add text to it. So maximum inflammation is 20, minimum inflammation is 0, and standard deviation, blah, blah, blah. Wonderful. So that is beautiful. So we can even get a little more complex. So we can say sometimes we want to look at variation in statistical values, such as maximum inflammation per patient instead of per everybody, or average from day one. Actually, I'm going to move this down so I can see it. So let's do patient. Let me move down here so we can see what we're doing too. Patient 0 equals data. I'm going to say take only patient 0, which is really patient 1. I'm going to be making comments about that like this whole course, like it blanks me. It's like OCD. So 0 on the first axis rows, everything on the second. Remember, since we didn't include a second value, we're saying everything on the first. And then we're going to say print maximum inflammation for patient 0. So essentially what this is doing is it is taking patient 0 only and then looking across all the days and finding whatever the highest inflammation is. So you can see that it's 18 for patient 0. Let's do patient 2 now. So we can do something like this. Print maximum inflammation for patient 2, NumB, Amax, data 2, and that's it. So we should get that the maximum inflation for patient 2 is 19, which is great. So what if we want to do something like this? So say that we want to get the maximum for every patient. So instead of having to type out, what was there, 60 patients or 40, I can't remember if it's 40 patients or 60 patients. What if we want to get everybody's max, or what if we wanted to get everybody's average, or each day's average? So here you can see that this would be like a column, average, 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 or we could do the max for a patient, patient 1, max, 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 max. What if we wanted to do something like this? What we could do, print numpy mean data axis equals 0. And run. So for this, we get to ask for the average across axis 0. So we'll get the axis. What was axis again? All right. So hold on. So if we do print numpy mean data axis equals 0, now we do shape. Whoops, where did I say stop? Oh no. I don't want to interrupt this kernel. I hope that didn't. Oh, maybe this is right. NumPy. There we go. So this tells us, the expression 40 tells us that we have at the average inflammation per day for all patients. So that's what this is. So you can see that some patients had no inflammation. Some patients, this guy had a lot, 13.25, but this is average over per day. And now, or no, so this is, sorry, average per day. So this is across all patients, right? So on whatever day this was, there was a lot of inflammation. We started with 0. So this must be some sort of like drug trial or something. I should look into what the actual data is to make it more biologically relevant. But it looks like they started with 0 and then they went up and up and up and it just continued to go up. It's kind of a bell-shaped curve, it looks like. So 5, and it looks like the peak would be here, 13.25, which is about halfway. So it looks like a pretty normal shape distribution. And then it started to regress down to nothing. So what if we wanted to do the average per person? So numpy mean data axis equals 1. So instead of axis equals 0, we do axis equals 1. And we get, this is the average per person. So the average, let's pull this back up. Oh no, what did I do with my, hold on. Let's see if this is gonna, all right, we're gonna look at it this way now. So axis 0 is, oh, sorry, it shows it down here, right? All right, so if you want to do the averages of the columns, numpy mean, whatever your data, saved data is, and then axis equals 0. So that will give you the column averages. If you do axis equals 1, that gives you the row averages. So things go column and then row. So axis 0, then axis 1. And so that's where we got those values from. And I think, what are we at? 14. I think that's where we're gonna stop for here. So remember, if you've continued on your last sheet, the analyzing patient data, make sure you save it. It should say at the bottom, saving complete. Or you could save it as part 2 if you wanted to. Wrong buttons here and there. So that's it. So that's kind of just a little more basics. We got some averages for our inflammation data. We gotta walk before we run. We'll get into some bioinformatics stuff as we go, but we're kind of familiarizing ourselves with Python a bit here. If you're watching on YouTube, hit like, hit subscribe. If you're a student of mine, hit like, please. So I have a little counter here. 89,000 views of my videos, which I'm very grateful that people actually watch these. Most videos have 1 like. So if I totaled up the 89,000 views compared to the number of likes, is probably like, I might not have 89 likes. It's 89,000 likes. So please give me likes. It helps my videos go to the top when people search, and then they find cool videos. If you try to go, get out of my soapbox for a second. If you try to find videos like the ones that I've created on YouTube just by searching, you probably don't find a lot of stuff. I never did, and that's why I wanted to make these. And so that's why I'm really passionate about getting them out there and getting people interested in the stuff. So anyways, hit like, hit subscribe. We'll continue on our Python journey with more analyzing data, I believe is the next video. We'll continue on that path. So thanks for watching, and I'll catch you in the next one.